Hello, this is 5.2 day, day one, working on verifying trig functions. In example one, it wants us to verify secant squared theta minus 1 over secant squared of theta is equal to the sine squared theta. To do this, you're trying to use your trig identity sheet to try to make the left side of the equation match the right side of the equation. So we want to take this over here on the left and make it into sine squared theta. The first thing I'm going to do is I'm going to replace secant squared theta minus 1 with tangent squared theta. That's because secant squared theta minus 1 equals tangent squared theta, and I believe that's right on your formula reference sheet. Step 2 is I'm going to replace tangent squared theta with sine squared theta over cosine squared theta. And I'm going to replace secant squared. This is 1 over secant squared, and 1 over secant squared is equal to cosine squared. I notice here that the cosine squareds cancel out, leaving me with sine squared theta equals sine squared theta, and that's how you do example number 1. I got the left side to look like the right side. Okay? I want you guys to try number 15. Go ahead and press pause, try to work it out. Okay, now that you're back, let's go ahead and go through number 15 here just to make sure that you did it correctly, or if you need some help. First thing I notice is that cosine squared is the same thing as 1 minus sine squared theta. How do I know that? Well, out here to the side, I know that sine squared plus cosine squared equals 1. If I subtract sine squared from both sides, I get 1 minus sine squared. And so I'm going to replace cosine squared with 1 minus sine squared, and then minus sine squared of theta. Negative sine squared theta, negative sine squared theta makes negative 2 sine squared theta. And that's all I have to do on number 15, because now the left looks like the right, and now I've verified that. Okay? Let's go ahead and move on here to example number 2. Example 2 is another verify problem. This time, though, we're trying to make the right side look like the left, and it tells us here that we should combine the fractions before we use the identities. So how am I going to combine fractions here? Well, I need a common denominator. My common denominator is going to be 1 minus sine squared theta. How do I know that? Well, if I multiply these two denominators together, it gives me 1 minus sine squared theta. So for the first fraction, in order to make it look like 1 minus sine squared theta on bottom, I have to multiply it by 1 plus sine theta, top and bottom, 1 plus sine theta. On the right, I have to multiply by 1 minus sine theta. And that's going to give me, after I multiply all that out, on top, 1 plus sine theta over 1 minus sine squared theta. Because if I multiply these two together using distributive property, it gives me 1 minus sine squared theta. Plus the distributive property here gives me 1 minus sine theta over 1 minus sine squared theta. Now when I add the two fractions together, my common denominator stays the same. 1 plus 1 is 2. Sine theta plus negative sine theta cancels out. And I have 2 over 1 minus sine squared theta. Well, now I'm going to use my Pythagorean identity, the one that says sine squared plus cosine squared equals 1. And if I subtract sine squared from both sides, I'm left with, sorry, not 1 minus cosine, but 1 minus sine squared. So I'm going to take out 1 minus sine squared, and I'm going to put in cosine squared. So I'm left with 2 over cosine squared theta. Well, when cosine squared theta is on the bottom, that is the same as secant squared theta. And so my final answer is 2 secant squared theta, which matches the original problem. Therefore, I've just verified the trig identity. Okay? Try number 39, please. Number 39 is right there. Write it down. Then please press pause and try to figure it out. Once you get it right, come back and check your answer. If you need some help, check out how I did it. Alright, so for 139, or for 39, I have sine x plus sine y and on the bottom, and cosine x plus cosine y on the bottom. Looks like I'm going to need a common denominator. My common denominator is going to be sine x plus sine y, and then times cosine x cosine y plus. Alright, so that means I'm going to have to multiply top and bottom here with cosine x plus cosine y for the right one. So on the left one, top and bottom by sine x plus sine y. Okay? So after I multiply top and bottom, do distributive property, that gives me cosine squared x. And then this is going to give me positive cosine x cosine y. Then on the bottom here, it's going to give me negative cosine x cosine y, so that's going to cancel out. And that'll leave me with minus cosine squared y, and that's the first fraction. And then plus distributive property, sine squared x. And then sine x sine y, negative sine x sine y, so those cancel each other out. And minus sine squared x. Or sorry, minus sine squared y, like that. Okay? Now this is all over sine x plus sine y times cosine x plus cosine y. Okay, so there's the first step. Add the two fractions together. And remember, I'm trying to get this thing equal to 0. Alright, so what I notice next is, if I have cosine squared x and sine squared x, they're being added together. Well, I know that cosine squared plus sine squared equals 1, so that makes 1. And if I have negative cosine squared minus sine squared y, let's do that over here to the side real quick. Negative cosine squared minus sine squared, and they're both y's. If I factor out a negative 1, it leaves me cosine squared of y plus sine squared of y, and that equals 1. So it's negative 1 times 1, which is negative 1. So I have 1 minus 1 over sine x plus sine y times cosine x cosine y, like that. 1 minus 1 is 0. And some zeros on the top. Final answer is 0, which verifies the trig identity being equal to 0. Kind of a tough problem, but if you work through it, it should make sense. Example 3, another verify problem. We're still trying to verify. This time we're trying to make the left equal to negative tangent squared of x. Okay? So the first thing I notice is that the tangent squared x plus 1 is going to be equal to the secant squared of x. So I believe the trig identity itself, let me look this up real quick, but I'm pretty sure that's what it says. The identity says 1 plus tangent squared equals secant squared. That's an identity right out of the book. So I'm going to replace that with secant squared of x. Cosine squared x minus 1. If I have sine squared plus cosine squared equal to 1, if I subtract sine squared and subtract 1, I get cosine squared minus 1 equals negative sine squared. And so I'm going to replace this with times negative 1 sine squared x. We're getting a little bit closer to making that negative tangent squared of x. I know that secant squared becomes 1 over cosine squared x. And I know that sine squared x is equal to cosine squared tangent squared. Cosine squared x's cancel out, and because it was negative 1 in front, it leaves me negative tangent squared x, and now it looks like the right hand side, so I'm good to go. Go ahead and look at number 47 and see if you can figure that one out. Now the question you have for me is, I'm pretty sure that you're thinking on this problem, is how on earth did he go from sine squared to cosine squared tangent squared? Well, this is what happened. I know that tangent squared x equals sine squared x over cosine squared x, and I needed to get rid of that sine squared somehow, and I needed to get a tangent squared. So what I did was, is I multiplied both sides of this thing and made it cosine squared tangent squared equals sine squared x. So essentially I multiplied both sides by the cosine squared. By doing that, I knew I could eliminate that bottom cosine squared and that top cosine squared, leaving only tangent squared, and that's why I did that. Okay? Go ahead and see if you can figure out number 47. And I'll give you a hint. You want to deal with common factors a lot on this one. Press pause, see if you can figure it out. Okay, you've either given up or you figured it out, but this is what I recommend on the first sudden. I notice on these first two terms, there's a common factor of 2 secant squared x. So that gives me 2 secant squared x times 1 minus sine squared x, and you know where we're going with that. That should be cosine squared. And over here, common factor is -1, and that's times sine squared x plus cosine squared x. So there's the first step. I know that 1 minus sine squared x is the same thing as cosine squared x. So I have 2 times secant squared x cosine squared x. And I know that sine squared x plus cosine squared x is equal to 1. -1 times 1 is just 1. And now I'm down to this. Well, I know secant squared is 1 over cosine, so now it's 2 times 1 over cosine squared x. Cosine squared x minus 1. Cosine squareds cancel out. 2 times 1 is 2 minus 1. 2 minus 1 is 1. And there, voila, I've just verified that the whole thing is equal to 1 by using trig identities and properties. Alright, last example for today is example 4. Converting to sines and cosines to help verify. Alright, so one trick on this, when it says convert to sines and cosines, it wants you to use sines and cosines. Pretty simple. Tangent of x is sine x over cosine x. Cotangent x is cosine x over sine x. Common denominator is going to be cosine sine when I add them together. So it looks like this one I need to multiply it by sine to get and by sine to get cosine sine. This one I need to multiply by cosine to get sine cosine. And now I'm left with sine squared x for the first plus cosine squared x for the second. Cosine squared x plus cosine squared x is equal to 1, and that's still over cosine x sine x. And we know that 1 over cosine is the secant of x. 1 over sine is the cosecant of x. And voila, it looks like secant cosecant. Therefore, I'm done. Go ahead and see if you can figure out number 49. Press pause, and then come back and see if you got it right. Again, try this using sines and cosines. Alright, now that we're back, the first thing I did on this one was to realize I want to try to take the left and make it equal to cosecant of x. Okay, so I made the cotangent. I changed that into cosine x over sine x. Sine x is still on the bottom. And I made tangent equal to sine x over cosine x. Well, you notice that when I cross things out, I have a cosine on top, cosine on bottom. A sine on bottom, a sine on top. Only thing left not marked out is 1 over sine. 1 over sine we know is the cosecant of x. and that matches the original problem, so I know I'm right. Alright, so if you look under the assignment page, day 1, 5.2, that'll tell you what you need to work on. Until next time.